Physically generated sound. Problem. Sound is an important part of perception and is also a physical phenomenon. If we can physically simulate motion, we should also be able to simulate sound. We have spent a lot of time discovering how to simulate a collision visually. If we can add sound into the simulation, we can also provide for a more realistic viewer experience. Approach. Sound is a mechanical wave that is an oscillation of pressure transmitted through a solid, liquid, or gas. Because of this, we have chosen to generate sound based on a mass-spring system for the objects in space. For each object in space, we first create a mesh, and then we use the mesh to create a mass-spring system where each vertex of the mesh is the mass, and the edges of the mesh is the springs. Upon collision, we simulate the vibrations produced by the mass-spring system at the location, and then we sum up all vibrations to generate a sound wave. Implementation details. The external libraries we're using are Fmod API for sound and Eigen for linear algebra calculations. The base code we're starting from is BoomBlocks. The paper we have chosen to implement is called Interactive Sound Synthesis for Large-Scale Environments. Implementation progress results. Step 1. Pre-processing. First, we integrated Fmod and Eigen into BoomBlocks. Next, we generated the appropriate data structures to prepare for the mass-spring system. On the left, you can see the output from each mesh that's being generated as we create new objects. Then we did calculations for the basic constants. We started first by simulating sound in MATLAB for simple objects. For example, here is a 3-node triangle mesh. Then we calculated the matrix representation of the mass-spring system. White represents connected particles in the mass-spring system, and black represents non-connected parts. For a given impulse at any node, here are the synthesized node responses from the mass-spring system. The result sounds like. Another example is this 8-node, 12-edge cube. Here is the matrix, and here is the resultant graph. Future works include completing the runtime processing and post-processing of the synthesized sound.